Hi everyone, good morning.
Good morning, sir.
Great. Can we start for the day, guys? Yeah, everyone, can we start for the day?
Mm, Yes, sir.
All right. So, guys, again, before we start, any questions or any doubts if you have that we should be discussing before we move forward? Again, it can be with respect to any concept, it can be with respect to a program, it can be with respect to further confidence or comfort needed around any particular item. uh, anything it can be, which we want to discuss it out, so we can spend again a couple of first 10 to 15 odd minutes discussing that before we move forward for the day. Yeah, Ali, Bhavani, Fatimatul, Tom, anything you would like to discuss, or we are good to start for the day?
that
Hmm.
that link function and all, no, that the connections between uh,
Correct.
link function. Yeah,
Correct. You want to discuss the
GLM.
link function?
Yeah, a brief about GLM. That's all. Link functions and
Okay, okay. So you want me to have a very quick brief on the link functions what we discussed last class, right?
yeah. Last time that
Okay,
GLM with the link functions and all. No?
correct, correct, correct. Fair, fair, fair. All right, all right. Thank you for that. Great, great. So guys, let's discuss the link functions first, right? So if you remember the link function, primarily we studied it in GLM. So we learned that in GLM there are two broad things what you need to cater to. First is the family, and second is the link function, right? Now, family is nothing but the distribution of y. Just a quick reminder in case someone forgot or in case you don't remember. It was nothing but the distribution of your response y, correct? And we said that y can take any distribution as far as y belongs to your exponential family, correct? So is exponential family exponential distribution? No. If you remember in yesterday's, not exactly yesterday, but in the previous lecture, I showed you something of an, EXP formula. If you remember in my word note, I showed you that formula. It was a big, heavy formula. If you can write the distribution of y in that particular format, then you say that y belongs to exponential family, and hence you can build a GLM on top of that, right? So you can make a Poisson regression, you can make a gamma regression, you can have family as negative binomial, you can have family as normal, uh, you can have family as binomial, all of those different distributions available, so that you can cater to different types or different distributions of y, unlike linear regression, which only caters to y following normal distribution, which in reality does not cater to a lot of scenarios, right? For example, in an insurance problem statement where distributions are majorly positively skewed. Yeah. So that was about the family part. Link function, in very simpler terms, I would say it is nothing but how you link your left hand side and right hand side of the equation, right? So this is nothing but the equation what we have studied till date, right? So link function, one of the primary use case of link function is to kind of, rescale the value, not exactly rescale, but kind of uh, ensure that the value of y is within a certain range, right? Now, what do I mean by that is, if you kind of model this equation, right, y equals beta naught plus beta 1 into x, so on and so forth. So your y technically, can take any value, let's say from the range negative infinity to positive infinity, right? Now, at times, correct, if I'm trying to model, let's say claim count, So my y, which is a random variable, let's say if it is a claim count. Now I hope you would appreciate that claim count technically cannot be negative, right? So at least theoretically, I may not want to use a structure of regression that can take negative values, right? So when you take log link function, you kind of change the entire structure into something like this, let's say. And because of which the range of y restricts from 0 to infinity, right? Now this makes sense because even though my, let's say, y cannot take negative values, in a claim count situation, I'm comfortable saying that the claim count is very small because the customer may be very less risky, but a negative value won't be, devised into your premium. So just for your understanding, when you calculate premium in an actual setup, you use claim count and let's say claim amount as well. So if your claim count is negative, kind of the premium what you will calculate would also turn out to be negative, which means that you are charging negative premium to the customer, which I hope you would appreciate does not make sense, right? So one thing is that when you apply link function, it's nothing but in very, very simple and crude terms, you are connecting the left hand side and the right hand side of the equation with something, right? Whether it is log, so you apply log. Whether it is, inverse, you would take y to the power -1. Whether it is identity, you will just keep y as it is. So one benefit is that it kind of restructures everything as per the range of y, correct? What exactly you want your output in form of in that scenario, correct? Tom and everyone, is this first part clear?
Yeah, that means we are not restricting the value of x. X can take any
Correct.
value, but
Yes.
the provided if x is negative means b0 should be that b0 plus b1 x should be greater than 0. No?
Correct, correct.
Yeah.
That's absolutely right. Because if I just, throw the log away from the left hand side by taking anti-log, obviously. So my expression becomes e to the power beta naught into e to the power beta 1 into x, right?
Yes.
So now exponential by the very nature, the range of any e to the power x, let's say, belongs to, the minimum value what it can take is 0 and the maximum what it can take is infinity. So you would never get, and obviously multiplier of any two positive numbers, would be positive only. So you would never get a value that is less than 0. Yeah. So I think this is one major, element as to why exactly, link function helps. So that, you kind of modify or change the output into, something specific what you want to cater to.
So this is the value of the distribution of y is distribution of y is the exponential family.
Yes. So there are two things. One is the
It
link
is
function, and then comes the distribution of family. So that is a separate thing what we discussed in point 1. So y can be still normal, for example. Y can still be Poisson. Y can be gamma. Y can be any distribution with respect to exponential family, and yet have a log link function. So log link and the distribution of y are two different elements what we're trying to understand. They don't exactly go hand in hand.
Yeah, if the link function is log, this is to be positive value of the. So if it is if the log if it is identity function, it can be negative also. No.
Yes, absolutely, yes.
So
In
we
an
have
identity
normally.
setup, your values may go negative as well. Yeah.
Yeah, normally we have link functions. We have log link functions, identity function, and inverse is there. So there.
Correct. Absolutely, yes.
That link function is that identity function is for distribution of y can be belongs to normal family. It can be normal family, but
Yes.
if it is log link function, it can be of those distributions whose value is greater than y, like greater than 0, like.
Yes.
And inverse is also, it can be negative also, no, for gamma and all.
Yes.
For inverse is for gamma, no.
Correct. But even if you remember, I told you last time that in insurance, you kind of use gamma distribution to model, claim severity or average
Get
claim count. Sorry,
claims
average
amount.
claim
Yeah.
amount. Yeah.
Yeah.
So even in that scenario, despite your Y being gamma, you still choose a log link function,
Mm.
right? Because again, claim amount can also, by the very nature, cannot be negative.
Yes. Yes. Yes.
Yeah.
Normally, we use this exponential family comes normal, exponential, gamma, binomial, negative binomial. Only these five distributions are
You have Poisson also. You have something called as a Tweedy distribution also.
PD distribution. Yes.
Yes. So you have all of these distributions also. So it's not only restricted to 3, 4 distributions.
Normally, yeah. But yeah, if the y is a log normal distribution, then the
Mhm.
no use of log link function. No.
No, log normal is different, right?
Yeah, no, if the distribution of y follows in the parametric, I mean, the log normal is not following that. Log normal also follows that exponential family,
I honestly, I don't remember whether log normal does belong. I don't remember actually at the moment. I think log normal does not belong to exponential family. I will have to check this one. I don't exactly remember. I think log normal does not belong. I
Does
will
not.
have to check. I'm not 100% sure on that at the moment.
Yeah, log normal. Then it is. Then there is no question of this link functions and all.
Why?
In log normal, the log if it is the data is not belongs to the log normal distribution, no,
Mhm.
no question of link function. We cannot use this. We cannot model this using
Acha,
link.
GLM, then you're saying.
Yeah, GLM. Yeah.
Yeah, absolutely.
Okay.
Fair enough. Yeah, fair enough.
But 3D is not distribution is not in the syllabus, right?
No, you don't have 2D. 2D,
Only yours,
you have.
only these three distribute. Normally, we have link functions, log link function, identity function, and inverse. Only we usually normally come across, right?
Yeah, absolutely. And plus, when we learn logistic regression, I think the
Yeah,
last one would be
yeah, because
logistic regression.
y
That one,
belongs to 0 and 1, na?
absolutely, yes.
But logistics also belongs to that exponential family, right?
Yeah, because Y is binomial, right, in that case.
Yeah, binomial,
So,
yes.
yes, so that again belongs to your exponential family. Okay, great. I think we had a good discussion. All right, great. So, guys, today we will be closing something called as feature selection, right? What is feature selection? Why do you need this? What are its type? And some various sort questions. Is what I plan to close before we close today, right? Before about 8:40, right? So let's try to close all of these pointers off before we close for the day. Okay. So what is it that you understand by the term when I say feature selection? What do you mean by the term when you hear feature? What would be feature?
It's
Yeah, anyone?
it is all about link functions and all. GLM.
Okay, 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 all right.
Features of GLM.
Okay, fair. So guys, whenever I say feature selection, the term feature over here stands for your X, right? Or regressors or independent variables or explanatory variables. Everyone good to go? So feature selection is nothing but when I say feature, I'm trying to I'm trying to talk about the excise in the model, right?
That's independent
Select,
variable.
yeah, absolutely, the independent variable. And when I say the term selection, this methodology or this framework is going to help me select the best regressors or the best excise or the best independent variables out of the pool of all independent variables what I have, right? Now the objective of feature selection is very simple, that if you are given 100 excise, not all excise or not all 100 excise would help you contribute or predict towards Y.
That means
Right?
parsimonious.
Yeah. So I don't want to, include all those 100, out of which some may be garbage, right, in my model, because we have already learned before that I want to ensure that my model is as lean as possible. I want to ensure that my model is as less complex as possible, right? So if any variable which is not exactly helping me add any value, I don't want to probably keep that in my model, right? Guys, do you understand the statement?
Yes, sir.
Great.
Yes, sir.
So how do I ensure, or is there any methodology that will ensure that only those excise which helps me predict Y are kept in the model? The remaining guys are automatically thrown out of from the model, right? So to do that, this is where we have feature selection into the place, which will basically retain only those excise which helps me predict Y, and it will throw out all the other regresses in the model or from the model, because I want to ensure that my model is not unnecessarily being made complex. Is this making sense, everyone? Okay, thank
Yes.
you. So guys, I'm just making some random model here, right? And let's say I draw a summary of model. Okay. So Anushka, if you can tell me, at 5% level of significance, how many regression coefficients are significant here? Anushka, at 5% level of significance, how many regression coefficients are significant here on the screen? Anyone else would like to make a try?
All are significant because all are greater than p. All this value p is greater than 0.05. Correct.
Yeah, so if it is greater than, then is the null hypothesis being accepted, or is the alternative hypothesis being accepted?
Null hypothesis we reject it. If it is p is greater than we fail to reject.
No. Yeah,
That
yeah, you fail to reject H naught.
yeah, H naught. Yeah.
H naught is insignificance of a regression coefficient,
Yeah,
or it is
insignificance. Yeah,
significance?
insignificance.
Insignificant, right? So then all
Yeah,
are insignificant, right?
yeah, except alternative hypothesis. Yeah, for all these things.
You accept the null hypothesis.
No, no, we here all are significant. So uh, we reject. We accept only. We accept all alternative hypothesis, right?
Okay. Anyone else would like to pitch in here?
Because
Sir,
if we accept null hypothesis, then it will be we are. Yeah, I'm sorry, sir. We are rejecting the null hypothesis, right? Correct.
We are accepting the null hypothesis. Yeah, yeah. You want to add up something here?
I was saying we are accepting the null hypothesis. That means all are insignificant.
Yes,
All are
absolutely
significant.
right. You are accepting the null hypothesis. So the statement says if the p-value is less than alpha, then you reject null hypothesis.
Yes, yes.
Here, p-value is not less than alpha. So you will not reject your null hypothesis, which means that you will accept your null hypothesis, which means that the regression coefficient is insignificant. When I say it is insignificant, which means it can be said to be equal to 0. Anushka, Tom, are we good to go here?
Yes, sir.
And if it is equal to 0, then it can be a dummy variable.
Yeah, if it is equal to 0, then it should be basically thrown out of the model. Yes, absolutely.
Yeah, it should be a garbage variable.
Yes, yes, absolutely, absolutely. Great. So, guys, if you see here at the moment on my screen, none of them is
Value greater than any value less than 0. Correct here. No, all are greater than 5. No.
correct. All are greater than 5. Yes. Then for all of them, you would accept your null hypothesis, which says that the regression coefficient stands at 0.
Yes.
If I say it is at 0, then 0 into anything in the equation is 0 only. So there's nothing impact being catered by that particular regression coefficient. Kind of throw it out from the model. Guys, I hope this is clear. We'll be discussing this from quite some lectures now. Everyone comfortable with this?
Yes.
Okay.
Yes.
Thank you. So now, if you see this model, I hope you would appreciate that you kind of, you would say that, okay, none of the regression coefficient is significant, right? The point I'm trying to make here is that till date, one method, what we have learned, right, to identify whether or not, a regressor is a garbage variable or not, is to see the p-value and then comment. Everyone, do you appreciate this is one method what we have learned? How do you ensure that a variable is garbage or not? Correct?
Yes, sir.
But now tell me, let's say I have, three models on the screen for you guys. Right? Let's say I have three models. Can anyone tell me the effect of x1 in the first model, the effect of x1 in the second model, and the effect of x1 in the third model? Will the effect of x1 or will the impact of x1 in all the three models be the same?
No, it will be. It won't be same. It will be x2. The effect of x1 will be maybe decreasing also, but it was not same because x2 has some value added to it. Now, x2 and x3 have some kind of impact, unless it is a garbage variable. Like
Fair. Yes. Yes.
Sir,
Absolutely.
are they like the three exercise are independent or dependent?
X1, x2, and x3 are talking about.
Yes, sir.
You can consider them to be moderately correlated, weak to moderate correlation. Yeah, that helps.
Yes, sir.
So, is absolutely correctly mentioned by Tom here. So, if you appreciate, the effect of x1 would broadly not remain exactly the same in all of these three models. The whole reason behind that is when I add x1 along with x2, so just like all regression models, what we're trying to understand here, are nothing but a multivariate modeling technique, right? When I say it's a multivariate modeling technique, it kind of takes into account the effect of x1. I'll repeat, it tries to take into account the effect of x1 in the presence of x2, right? So when x2 is present in the model, the impact or the performance of x1 may differ. Similarly, in the third model, if you see, the impact of x1 in the presence of x2 and in the presence of x3 may again vary, right? Everyone, are we very clear with this?
provided they are x1, x2, x3 are uncorrelated. No, if they are correlated means then it may have some effect, right?
Yeah, that's why we said, let's consider about, weak to moderate correlation only, let's say for now.
Yeah, if you have moderate correlations, then there will be this x1, x2 have some effect. If they are independent means Yeah, unless they are garbage variable.
Even then, yeah, let's not consider garbage variable for now. Even then, if they're independent and if you try to kind of add x2 or x3 in the picture, the impact or the role what x1 might play might differ, right? Yeah.
So can we have some example for X1, X2, X3?
Yeah, fair. I think we can do that. Not a problem. I'll just switch back to empty cars. So let's say here I have weight, and let's say here I have weight plus displacement, and let's say here I have weight, displacement, and let's say q sec, for example. I'll just run all the three guys here, right? Okay. So technically, if you see with weight, the coefficient is -5 approximately. The moment you add displacement in the game now, that -5 changes to -3. And the moment I add, let's say, qsec as well, it again changes from -3 to -5, right? Everyone. Also, if you see here, it was significant at 1% level of significance. Here it was significant at 5%, and even in the first one, it was significant at 5%, right? So what I'm trying to tell is that as and when you keep adding more regressors to the model, or you keep removing some regressors from the model, the effect or the impact, whether it is in terms of significance, in terms of the beta coefficient, things tend to change as new information of new regressors adds in the model or gets removed from the model. Is this clear, everyone?
Yes, sir.
Ria, others, Bhavani, Anushka, Ali,
Yes, sir.
right? So, yeah. So, basis this understanding, if I directly dump all the variables, basis this understanding, if I directly dump all the variables in the model, and then if I try to see whether the p-value is significant or not, that may not be an appropriate approach to take, because weight in the presence of all others may have some impact, right? So if you see here, weight also at 5% level of significance is not turning up to be significant, right? In fact, no other variable is turning out to be significant. Guys, is that making sense? So that does not mean that, okay, the entire model is a garbage thing. It is just that since you dumped everything at one shot, you dumped all the variables in one model at one go, all the variables are performing in the presence of another one. Hence, you are not being able to, filter out the true excise individually. Hence, there is a different method that I need to now introduce to ensure that helps me select the best excise in the model, which is nothing but what we will learn today via the element of feature selection. As to how do I exactly select the key best feature selections, because just dumping and seeing this summary is not helpful at the moment. Is the entire framework or is the entire story clear?
Yes, sir.
Okay, great. Thank you, Bhavani. Anushka, Ali, Fatimatul,
Yes, sir.
Ria. Okay, great. Thanks. All right. Then, without further ado, let's get started with the very first method of feature selection. Right? Now, pay very careful attention, everyone, because the very first method, ka extension, is nothing but the second method and the third method as well. So if you understood or if you understand the first method very well, the second and third are just, kind of very easy to understand, right? So the very first method what we will be studying today is something called as a forward selection, right? Everyone ready for this?
Yes, sir.
Okay, great. So guys, this feature selection method works in various stepwise method or works in various iterations. Okay. When I say various iterations means it goes like step 0, step 1, step 2, step 3, step 4, step 5, right? Basis some criteria. So in forward selection, my step 0, right? In forward selection, the very first step what you take, right, is to make a null model. Yeah. What do you mean by a null model, anyone? So forward selection says that at the very first stage, you make a null model.
Only intercepts element is there. No?
Yes, very good. Whenever I say, guys, that we are making a null model means that only intercept is in the model. That means no xi is in the model. So you write lm to make a model. Let's say I'm trying to predict mpg, right? And since there is only the intercept term, you write tilde 1. Correct? Instead of writing the name of your regressor, you only write the number 1 to indicate that only an intercept term is to be fitted. I will also just run the model and show you guys. So if you see, when I run the model 0, it only shows me an intercept term that is nothing but a 20.09 number. No excise coefficients. Is this simple? Good to go, everyone?
So like
Mm-hmm.
MPG tilde 1, what does that means?
So MPG, if you remember, you used to always write MPG tilde some excise information here. What all excise are to be included.
Yes,
If you
sir.
write 1, then it is an indication to R that my model is not y equals beta 0 plus beta 1 x. Instead of fitting this model, only fit this model. So this is what, if you see, I mean by a model with only an intercept term. Only beta 0 is in the model.
The intercept term will be the arithmetic mean of y's.
Yeah, correct. Which is nothing
Correct.
but y bar. Yeah.
Yeah, y bar.
Yeah.
Sir,
Yeah.
so
Mhm.
like 1 means we are taking only the first term from the equation. Is it like that?
Yes, yes, yes. So first, so rather think of it like when I write 1, it only means that I'm talking about only the beta naught term. So I'm saying only give me beta naught estimate. That's it.
Okay, sir. Got it.
Yeah. So only if you give some x value, it will try to work with x. If you don't give any x value, if you only give it 1, so think of it like this. If you want beta 1 hat, you give x. Guys,
Yeah.
Yes.
if I want beta
Yes,
naught
sir.
only, do I have any associated with beta 1, beta naught?
Yeah, beta and then beta 0 plus beta 1 is the slope variable we are putting it.
No, no. Is there anyone you see with beta naught? So with beta 1, you see
No.
x.
Yeah. Beta 0, there is intercept variable now.
Correct. But do you see any x value or do you see any multiplier term here?
No, it won't be because intercept no.
Yeah. So can I write into 1?
Into 1, yes.
So that is why the term 1 comes here.
Yes.
Yeah, I hope that helps.
Yeah, yes, sir.
Yeah. So that is why when you just write tilde 1, it's only talking about the interceptor. Yeah, great. So let's say I have MPG as my y, and let's say I have 3x. Let's take weight, let's take displacement, and let's take qsec, right? Let's say I only have these 3x, and now I want to use forward selection to tell me out of these 3 which 3 I should select to predict y. Is the problem statement clear, everyone?
There are 3 x's we are selecting, right?
Yes. I have manually selected 3 xis, and now I want to use forward selection to tell me that out of these 3 xis, which xis should I use in predicting MPG? Should I use all 3? Should I use only one of them? Should I use either of the 2? All 3? What is the answer? That is what forward selection would tell me.
which we have to throw among these three. One can be a garbage variable.
Yes, one can be garbage, two can be garbage. I don't know at the moment.
At
That is
least
what
one can
forward
be.
selection would help me understand.
At least one can be a garbage variable.
Yeah, it can be. Absolutely, it can be, or may not be as well. That is what forward selection would tell me now. Everyone, is it clear?
Yes, sir.
Okay.
Yes, sir.
So, okay, step 0 is very simple, right? If I calculate the accuracy of model 0, can anyone tell me what will be the adjusted R square or what will be the R square for this model? For a null model, what is the accuracy, everyone? If there are no xi's in the model, have you given any brain to the model?
No.
If there is no brain, then would you expect any accuracy?
It is a mean. That variable, that x0 will be the mean of the y.
Correct. So there's technically no brain to it, right?
Yeah,
So
correct.
would you expect any accuracy in that case?
It will be something like R square will be near to 0 or something like that.
Yes, the R square would be exactly 0 in that scenario. Guys, see if you understand this.
Yes, sir.
Intuitive, right? Great. So step 0 in forward selection is always that you start from a null model, right? Step 1 is now you start to create a competition between all the xi's, correct? Step 1, I will repeat. You start to create a competition between all the xi's. What do I mean by a competition is that you will now add one variable inside the model and try to compare which one of them is giving you the best accuracy. So let's say one model will be with only the weight term, one model will be with only the QSEC regressor, and the third regressor was displacement. So one will be only with displacement, right? So I have three different models, and then I'm trying to see out of these three models, which regressor is giving me the best accuracy out of all of these three guys. Guys, is it clear what I'm trying to do here at stage 1 or at step
We are
1?
taking only B1. Among these, only one will be B1, right?
Yes, here in every model you only have one xi. So all the three models are simple linear regression. So you will only have one beta, one hat.
But sir, in summary, you in all cases you use models.
Thank you. It will be model 1 in all three. So I am overwriting. If you want to give different model names to each one of them, that is completely fine. I am just overwriting because I am getting the summary right below. So there's no point in creating a different model name as per me. If you wish to create a different model name, you are completely feel free to go ahead and do that. Is the stage 1 of competition clear, everyone, between all the regressors?
Yes, sir.
Okay. Now, once you create a competition, you try to see which one of them is yielding you the best accuracy. So you try to see what is the adjusted R square when each of the regressor performs. When weight is in the model, you see an accuracy of 74.5% approximately. This is 71% approximately. This is 15% approximately. So out of the three variables, which one of them is the best variable or which one have outperformed everyone else?
Weight is 74%.
Yes, absolutely right. It is the weight. Hence, at the end of stage 1, weight enters the model, right? What do I mean by that is, I mean by that model 1, this program is my final set of program. So at stage 1, this is the model what I finalized. Is that making sense, guys? Are we comfortable till here?
Yes, sir.
Okay, great. So now we will move on to stage number 2. I'm just copy pasting the entire thing below. Stage number 2. Hence model 2. Model 2. Now, since weight is already inside the model, right? Who are the remaining 2 competitors? Guys, which are the 2 other regressors that I'm yet to evaluate?
QSEC and
Cusick
Very
and
good. It is QSEC and displacement. So again, I will have a competition between the 2 regressors. Now, since weight have entered the model, weight is a permanent regressor. So at the second stage, the competition will be between weight, QSEC, and weight displacement. See if this is making sense.
so we are fixing weight and then we are adding to
Yes,
it.
yes, absolutely right. The moment any regressor enters the model, that regressor will now permanently reside in the model. So you kind of fix that particular regressor and try to see who's the next best in the line. Everyone, is this very clear?
Yes, sir.
Okay, great. So now if you again try to see the accuracy, what was my benchmark accuracy that we already have here? So this model had 74.5% accuracy now. Let's try to see what accuracy you get out of these 2 models. Yeah. So what was my previous accuracy at the end of stage 1? You see model 1 was my final model. So the accuracy was 74.5% approximately. When I add QSEC to the model, the accuracy improves to 81%. When I add displacement also to the model, the accuracy also improves to about 77%. But between the 2, which is a more higher accuracy, guys?
QSEC.
Absolutely right. The regressor with QSEC, correct? Hence, you say that at the end of stage 2, QSEC enters the model. So model 2 is nothing but weight plus QSEC. Model 2 finalized. Are we comfortable till here at stage 3, guys? Or stage 2, everyone?
End of stage 2.
Yes, sir.
Yes, absolutely right. This is nothing but end of stage 2. Yes, absolutely right. Yeah, Anushka.
sir, when we are performing stage 1, in that case, QSEC gives the minimum R adjusted R square, which is 0.1% something,
Correct. Good.
and displace gives the more higher, means
Second best
70%. Uh,
accuracy. Correct.
but when we are combining them,
Hmm.
so I thought in the head that weight and displacement should give the higher adjusted because
Correct.
they are independently give the higher,
Hmm. Hmm.
but
Good.
it comes very opposite. Why
Correct.
is so?
Good. That's a good, a very good observation. Now, Anushka, if you remember, that was the whole point, where I discussed the first point that, variables, the effect of displacement when weight is already being present in the model, the behavior would change very differently versus, with any other regressor. Over here, 14% was when QSEC was alone in the model, right? So when I combine QSEC with weight, since it's a multivariate model now, the performance when both of these guys, kind of act together would be very different when they act individually, right, Anushka? So the whole
Yes,
reason is that because, the information QSEC might be adding in the presence of weight may be much more higher than what displacement is about to add. I hope that
yes,
makes sense. So maybe
yes,
Weight has
displacement
weight has
on
weight
top
has
of weight is not being able to add too much additional information, while QSEC is able to add, hence that extra lift or hence that extra uplift.
Weight has more influence on QSEC rather than displacement, right?
Or you can say QSEC is able to give more additional information than, let's say, what weight is already being able to tell. That I think would be more appropriate. Anushka, I hope that's clear.
No, we never take about the talk about the relationship between QSEC and weight, QSEC and displacement, right? There will be three combinations, weight and QSEC, weight and displacement, and displacement, QSEC and displacement, right?
Fair. Tom, that is fair. But in forward selection, the objective of forward selection is not to test every combination. The objective is to just, kind of keep doing competitions and add one regressor to the model. So that third combination, what you're trying to talk would not be coming up over here, because forward selection is not trying to test every possible combination. It is just trying to see what all sequentially I can keep adding. So you will not have another combination of QSEC and displacement.
So first of all, we take first combination, forward selection, we take first one, and then we
Correct.
usually the first one with other two, right?
Correct.
Had we taken QSEC as a independent instead of weight, then we're gonna use QSEC and weight and QSEC and like that, right?
Yeah, but then that combination we're not trying to do over here.
No, but yeah. Only
That's
one
not how
selection.
forward selection works.
Yeah. Correct.
Anushka, I hope you are clear with your question.
Yes, sir, I clear. But when we are trying to interpret, how should I give interpretation?
So interpretation is that way only, that QSEC in the presence of weight is able to give me more information versus displacement. So let's say there's a lot of overlapping between what information weight gives you and what information displacement gives you. Since the information is the same, I don't have any extra value by keeping both of these guys. Versus when I add weight and QSEC is able to tell me something new, what weight was not able to tell. Hence the accuracy improves.
Yes, sir.
I hope that intuition is very clear, or that gives you that understanding.
Yes, sir.
Yeah. Others, are we good to go? Ali, Bhavani, Fatimatul, Riya.
Yes, sir.
Great. Great. Thanks. Now comes time for stage number 3, because we are left with one last iteration. So stage 3, guys, will be how many regressors left in the competition? Guys, how many regressors
Nothing.
left? It is only one, that is displacement. Correct? Yes, no.
Displacement we
Yes.
have figured out, no?
So you selected QSEC at stage 2, right? So
Yeah.
stage 3 is where I will also add displacement and try to see if now in the presence of QSEC and weight, is displacement helping me something with extra information. Correct, everyone? Guys?
Yes, sir.
Okay. So model 2 accuracy or benchmark was 81%. In model 3, now I have added displacement and I'm again trying to see the accuracy. So if you see the adjusted R square, when I added displacement, the adjusted R square reduced from 81% approximately to 81%. Sorry, 81 point, let's say 5% odd to about 81%. So did it help you by adding the regressor of displacement?
No.
No, right?
It may,
We
yeah.
learned- Yeah,
But it
yeah.
is very marginal only, no? It is 81% and 80%, you know.
Yeah, so here we will keep it very simple. Did it reduce or did it increase? We are not looking at the quantum at which it reduced or increased.
It is reducing.
Yes, absolutely. So in
So
this
we
one,
can throw it as garbage variable.
yes, absolutely. So we have learned already, right, that adjusted R square can reduce if you try to add a variable that is not giving you substantial information in the model, right? So by adding displacement, as you guys can see, kind of, the adjusted R square reduced, which means that displacement is not an appropriate variable to add it. Hence, you say at the end of stage 3, forward selection concludes, and your final model would be, everyone, your final model would be weight plus qsec. No displacement in the model because displacement is not helping you get the extra uplift. The adjusted R square reduced. Hence, you say that whatever you have achieved at model 2 or at the stage 2 is the final model. You will not add displacement within the model. Is the entire story of forward selection making sense, everyone?
Yes, sir.
Good to go, guys. Simple.
Sir,
Yes,
Yeah,
sir.
Pramali.
sir, could you brief this fully from first? A small brief.
For the entire process.
Yes, sir.
Yeah, fair. So the objective is that I cannot just dump everything in the model and then try to remove the excise basis p value, because the performance of a particular regressor changes in the presence of another regressor, right? So if you see this summary, kind of you would say that all regressors are garbage regressors because you technically don't see any stars, correct? However, that may not be true because weight in the presence of everyone else would tend to behave differently, right? That is why I need some another method which does not dump everything and then try to talk, which kind of helps me understand and give me the best set of exercise in the model. That is where feature selection comes into the place. And the very first type of feature selection, what we are learning at the moment, is something called as forward selection. Now, by the very term forward selection, it means that you keep on moving forward at every stage. When I say forward, means you keep on adding one regressor in the model at every stage. So how do you decide that? You start with a null model, which means model with no excise, right? Then at the very next stage, you try to create a competition between all regressors and try to see which one of them is performing the best. So you try to create simple linear regression models for every xi that you want to evaluate. Whichever performs the best, in this example, it was weight. Hence, I say that at the stage 1, since weight was the best or weight yielded me the best accuracy, weight enters the model. In forward selection, the moment any one regressor enters the model, it will remain in the model for its lifetime. It will never be removed, right? Hence, model 1 weight gets finalized. At stage 2 now, I am left with 2 more regressors, displacement and qsec. Hence, now I also add qsec and displacement individually in the model to try to see whether each of these models gets further improved or not, right? So again, here we saw that qsec yielded a better accuracy than weight alone. Hence, I say that at stage 2, my model becomes weight plus qsec, right? Now, again, I am also left with displacement. So at stage 3, I also kind of try to evaluate displacement. But since we saw that the adjusted R square, once displacement got added, the adjusted R square reduced. I am happy with 81.4%, but I'm not happy with 80.7%. Hence, I decide that I will not add displacement in the model. My model or my final evaluation is that weight and qsec are the top two regressors that I would be selecting. I would not add displacement in my model. Hence, this is your final model. Guys, see if the entire summary is helping out. Ali, Anushka, Bhavani, Fatima, Tulriya, Tom.
Yes, sir, got it. Like we will see the adjusted R-square and then decide.
Yes, you would see adjusted R-square at every stage and then decide whether to keep things in the model or not. If things are improving, you are more than happy to include. If things starts to reduce down, then you would try to cut it off from the model.
Okay, sir. So like here we have only 3 exercise. So like
Correct.
we are adding and finalizing. But what if we have more exercise?
Yes, if you have more exercise, then obviously the number of combinations what you will be testing will be a lot more. We do have a function in R to cater to that, but I will discuss or I will bring that function at a later level. Because then kind of you don't exactly understand how things are working. That's why I myself never started by kind of using that inbuilt function. I will teach you that, I will talk about that, but obviously the number of combinations would be a lot more higher, so that's okay for now. But we will definitely learn that quicker way of evaluating all X combinations in one way.
Okay, sir.
Sir, that p-value method is, we are not specifying all may be significance, but from that we are giving it to forward feature selection forward. We are testing one by one, right?
Yes, you are doing it in an incremental manner instead of a dumping manner. So this method, if you remember, was kind of the dumping method. You dump everything and then see who is good or who's bad. Forward selection is more of a sequential manner where you kind of keep on adding one regressor and try to see incrementally how things are performing. I hope that makes sense.
Forward is we are adding one, and then maybe backward will be we will be dumping. We will be removing one. Might be.
Yes. We'll learn about backward. Don't worry. We'll learn about backward as well. But everyone, are we comfortable with forward selection till here?
Yes.
Yes, sir.
Great. So now I will change the regressors for you guys. Yeah. So you guys will have to now perform forward selection on empty cars using these four exercises, right? And you have to tell me which one of them or what is your final model. Everyone, is it clear? For these sets,
Yes,
you
sir.
have to perform forward selection, what we just learned at the moment, and tell me the final model. Everyone clear with this? Yes, no? Okay, great.
Yes, sir.
Chalo, I'll give you guys about 7 odd minutes for this. Quickly perform and tell me which one of them is the most appropriate or which one of them are the most appropriate exercise. I will copy paste the entire code for my forward selection, what I did on the screen, also in your chat box. So you can refer to that and kind of work things around. Is that clear, everyone? Is that good to go? Yes, no?
Yes, sir.
Great. Chalo, take quickly about 7 odd minutes. Once you're done, let me know. We'll start to discuss that. So if you have any questions or doubts, I'm here only. Let me know. Even I am performing the stepwise in the meanwhile at the back end so that we can compare the answers. Okay, so I'll just stop sharing my screen so that you guys are not copy pasting my solution. Yeah, so great. Chalo, great. I am ready with my answer. You guys can, or we can, once you guys are done, take your time. Once you guys are done, we can kind of compare what my answer is. My answer in the sense, what is my final model versus what is your final model. Chalo, great. Let me know once anyone's done with that. We can try and discuss it. Acha, at least tell me at stage 1, which regressor got added?
CYL.
Yes, absolutely right. At stage 1, cylinder gets added to the model. Great, good. Chalo, keep going ahead. Done, Bhavani.
Yes, sir.
Great. Others? What's the status?
So can I get 2
Sir,
minutes?
give 1 minute.
Sorry, give what?
Sir, 2-3 minutes.
Okay, fair. Yeah, Anushka, even you wanted more time, or you wanted
Yes, sir.
to share some program?
Time, sir.
Okay, fair. Yeah, Bhavani. In the meanwhile, we can discuss what. Okay, so I think first stage you got cylinder. That's right. Which X gets added in the at the second stage?
This
Sorry.
displacement.
Yes, absolutely right. Displacement gets added at the second stage. What about third?
AM.
Yes, absolutely right. At the third stage, AM gets added. Good. And at the fourth stage,
All for HP also gets
sorry.
added. HP also.
Yes, absolutely right. At the fourth stage, horsepower also gets added. Basically, this was a scenario where all regressors, all excise, whatever you had on the plate, got added inside the model because each one of them was contributing towards the model, and hence forward selection selected all of them within them. So if you okay, I'll discuss once everyone's done. So yeah, I think fair enough. That's a good attempt, Bhavani. That's the right answer in the sequence what you did. Great.
Okay, sir.
In the meanwhile, if you can, if you want to, let's say, add any other regressor and do it a 5 combination thing, and then if you want to try and test that out, that's also what you can do, since we have 2 to 3 odd minutes more before we start to discuss things.
Okay, sir.
Yeah. Anushka, Ria, Ali, let me know once you guys are done. Yeah, we are waiting for you guys. So once you're done, please feel free to let me know. Or if you're stuck anywhere as well, again, same, please feel free to let me know.
Sir, so the first stage cylinder gets added.
Yeah, cylinder is the first regressor what gets added in the model.
Okay. In the second stage, displacement gets added.
Sorry.
In the second stage, displacement.
The second stage, yes, absolutely right. You have displacement in the model. Yes, good. Chalo, I think, guys, do you need more time or we can move forward? Anushka, Ria, Ali,
Sir,
I haven't heard anything from you today. Yeah, Bhavani, you have anything to add?
I have a doubt. Like,
Yeah, go ahead. Mm-hmm.
why is there any specific reason why we are selecting NPG as Y, or we can have anything as Y?
So broadly, if you understand, that is the only column in empty cars which makes sense to keep Y. So see, what is Y? It is your dependent variable, right? So the mileage of a car is dependent upon the features of the car, right? For example, what is the weight of the car? Heavier the weight of the car, lesser the mileage, right? Then weight of the car in a way is also, dependent upon, how many cylinders you have in the car, right? Then if you have more cylinders, you have more horsepower, you have more displacement, right? Maybe if you have more power in the car, then maybe it's a high priced car. In that case, it may be an automatic car. So kind of a lot of the factors are quite linked, to with respect to mileage in that way. So that is the whole reason I usually prefer keeping mileage as your why. But there's no specific reason. If even if you want, you can keep weight, as why, and then try to model things out.
For a car purpose, for a purchaser, for a car, he
Mhm.
is more interested in mileage other than weight of the car or something else. No?
Correct, correct. Fair
So
enough. Especially in the
mileage
low.
is more important because for a purchaser of a car, he will not go for weight of the car. He will not go for cylinder of the car. He wants to know the how much petrol I'm getting mileage, right?
Correct, correct. Nee, definitely for car buyers less than, let's say, with a price of 20 lakhs, for example, they will definitely, mileage is a very key factor. Less than 20, less than 50 lakhs. The moment I think you go beyond 20, 25 lakhs, I think mileage is also not a factor. There it becomes more of, engine power
So
and luxury or comfort, as compared to mileage in those
mostly,
scenarios.
mostly why comes from the objective of the study, right?
Yeah,
Objective is what
definitely,
is
absolutely,
specified.
absolutely. What
So,
exactly is
yeah,
that I want to predict?
I mean, definitely we are not interested in weight of the car, right?
Yeah,
For
yeah, yeah.
objective, if
Yeah.
objective is to study the weight of the
Depends,
car or
depends.
what
So
the car,
let's say,
then okay.
if it depends. So let's say if you're trying to make a structure and then you want to see what weight of the car it would lead to, again depends exactly on the study or the objective. Things may change here and there. So that's completely there.
Okay,
Yeah,
sir.
that why is related to objectives only.
Correct, correct. Acha guys, just give me a minute. I'll quickly get my charger. My battery is on 20% approx. I'll just quickly get a charger. Hold on. Yeah. Step one, cylinder displacement. Yeah. Yes. That's great, Anushka. I think even Ria had the same answer. Ria, are we good to go?
Yes, sir.
Okay, great. Great. Let me quickly share back my screen up here now. Everyone good to go with this thing? Guys, forward selection, is that clear?
Yes, sir.
Yes.
Okay, great. Great. Good. So now I am introducing a new concept here. So I have let's say two more agendas for the day now. First is that I want you guys to learn something about AIC, right? And second, we will close by backward selection. Good to go? Yes, no, guys. Simple agenda for the day. I think we have 20 odd minutes left. Should
Yes,
get
sir.
closed in the remaining odd time. Great. Have you guys studied or heard about the term AIC before?
ASC means it's accuracy, no?
Not exactly accuracy. It's more about the quality of the model. Not exactly accuracy because so it tells you a relative picture. So
A
even if
criteria
you
for
have the
rejection
best
or accuracy.
AIC or the best model, it may not be the best in terms of accuracy.
It may be accurate for, for criteria for accepted or rejection of
Hmm.
garbage variables, right?
Okay. Okay. Fair.
A,
Others, Have you heard the term AIC or have you learnt about AIC before?
No, sir.
No, sir.
Okay, okay, fair. So guys, the full form of AIC stands for Akaike's information criteria. You can see the spelling on my screen on the right hand side. Correct. So AIC stands for Akaike's information criteria. Just one thing is that AIC is not accuracy, right? So don't get confused or don't kind of think of it as a substitute for adjusted R square. Adjusted R square kind of directly tells you that, out of 100% accuracy, this much percent your model is accurate. AIC doesn't give you that information, right? What does it exactly gives us is something what we will learn in some another lecture. For now, or for today's agenda, I just quickly want to introduce how do you see AIC or how does AIC works, and then we will try to use AIC in a backward selection. So in forward selection, we use adjusted R square. Backward selection, we will do using AIC. Can I do forward selection using AIC as well? Yes, you can do that. You can do backward selection using adjusted R square as well. You can do any method or evaluation metric you want. That's completely fine. Fair. Great. So guys, AIC, or full form of AIC stands for Akaike's information criteria. Now AIC has two components on which it works, right? AIC has two components on which it works. I am just pasting the broad formulae of AIC here. Yep. So if you see the formula of AIC, you have one component with respect to log likelihood, right? You have another component which is plus 2 into k. Yeah, pay attention everyone. This component, what I have highlighted on the right hand side, plus 2 times k, is nothing but called as a penalty parameter, or is called as the penalty component. What do I mean by a penalty component, or why do you say it as a penalty component? Think of k as the number of parameters in the model. Okay. Think of k as the number of parameters in the model. Let's say till now, if I had 5 parameters in the model, and now I add a new x in the model, which makes the number of parameters in the model to 6. So my k goes from 5 to 6. If my k goes from 5 to 6, what is the incremental penalty I'm adding everyone here? Guys, what is the additional penalty that would be added?
1.
1?
No, it is a 2 raised to 5. I goes to 2 raised to 6. Correct. The condition 2 raised to 5 and 2 raised to 6. La? So
it is 2 into, not to the power.
2 into it. So it's 10 and 12.
So what is the incremental penalty that got added?
2
Yes,
got that.
absolutely right. Absolutely right. Since k is being multiplied to the component of 2, 2 is nothing but the penalty you're adding for adding every extra regressor in the model. Yeah. So when you take k from 5 to 6, the kind of penalty goes or increase by plus 2. If you add, let's say, 5 more regressors, so I hope you would appreciate that the penalty now would be 10 extra. So 5 additional regressors, 5 into 2 becomes 10. So total number of penalty becomes 20. Guys, are we following this? Yeah, Ria.
Sir, can you explain penalty again?
Yeah, I'll explain again. So AIC also thinks like adjusted R square, right? AIC says that you add more regressor in the model and it says I will penalize you, right? So 2 is nothing but the penalty. Correct? This 2 what I've written over here is the penalty. So you add 1x in the model, AIC says I will penalize you 2 units. You add 4 regressors in the model, AIC says I will penalize you 8 units. You add 10 excise in the model, AIC says I will penalize you 20 units. Is this right hand side term clear, everyone? So there are two components. I am discussing the second component first, which is the penalty component. AIC understands that adding more regressors, more variables in the model means you are adding more complexity. Hence, AIC says that, okay, you want to add more complexity, you add, I have no problem, but I will keep on penalizing you. And how it is penalizing? By adding 2 units of penalty for every X you add. Riya?
Yes, sir.
Everyone else?
So the every time a variable is added or an exercise is added, there is an additional penalty of 2 units.
Yes, yes, yes.
That means the less AAC is better.
Sorry, that means?
That means less AAC is better. That condition AAC is better now.
Yes.
If you add more penalty, that AAC will be more.
Yes, absolutely right. Yes, very good. He has made a very fair point, everyone. So if I keep on adding too much penalty terms, then kind of AIC would increase because there's a positive penalty, right? Hence, in AIC, if you guys can see my screen, there are two major rules what we have to know about AIC. The very first rule is that lower the AIC, the better. Often student confuses with adjusted R square, that higher the adjusted R square, the better. Hence, AIC is also the same. Higher the AIC, the better. That is completely wrong. Correct? AIC, lower the better. Adjusted R square, higher the better. Why is that so? Because when you keep on adding penalty, right? The first component, guys, the second component is the penalty term. And the first component is nothing but the log likelihood term associated with a negative sign. I hope everyone appreciates. Correct? So let's say if the first component is negative 1000 plus a penalty of 20. Let's say if I add 5 more regressors in the model, so the penalty would become plus 20 plus 10. Correct? 5 regressors means 10 penalty. But you see there is no improvement in log likelihood. It remains 1000 only. But if you add another 5 excise, and let's say now with that excise, this goes to 2000. Everyone, if you can try to compute basically all these three numbers, you would see that the third number is the lowest among the three. Correct? Everyone. So this AIC, the lowest AIC, is a better AIC as compared to the other two. Guys, were we able to follow that, guys? So what do I mean by that? See, what do I mean in very simple terms here is, you have component 1 and you have component 2. Component 1 is a good component, which means if at all your exercise are helping you, the first component, the log likelihood component, should ideally start to increase in absolute sense. Correct? Now, obviously, for log likelihood to improve, you will have to add additional parameters in the model. But AIC says if you add additional parameters, I will keep on penalizing you. So again, the same trade-off. If the penalty is very substantially small compared to what value got added inside log likelihood, just like if you see here, if you see line number 80 and line number 81, in both of these terms, a plus 10 penalty got added. But at line number 80, there was no improvement in the model. At line number 81, there was a substantial improvement in the model. Hence, even though you kept on adding the penalty term, it got wiped off by the improvement you brought to the model by adding that new excise or those new excise. Hence, if you see the AIC between all the three models, the least AIC is where you see the 2000 log likelihood number. Right? So you say that out of these three models, this model, the one with -1970 AIC is the best AIC or is the best model.
The likelihood function, that likelihood function is also a good factor, right?
Sorry, what is a good factor?
The likelihood function also is a factor, Nike.
It's a good factor. Yeah, absolutely.
But
You
they
would
are
like
not.
it to be.
They are not depending on the penalty, right?
Yeah,
Penalty
absolutely.
factor.
They are dependent upon excise definitely, but they're not dependent upon the penalty parameter. Yeah.
And this excise and penalty parameters are independent, right?
They are related in a way. I mean, the values what excise would take individually, that has nothing to do with the penalty. It's more on the number of X is what you have to do the penalty about. Yeah, Anushka, you have anything to add here?
Yes, sir.
Mm-hmm.
In the second step, you said that the no change in the log likelihood. So
Mm-hmm.
it is for us to understand that it is no change in the log likelihood, or it is very minimalistic change.
Yes, yes, correct, correct.
So means when we are adding more 5 regressor, it is that change it is very minimalistic that we consider it is at the no change in the model.
Good, good. You're right, you're right. Yes. You're saying it absolutely right. I don't have any further comments or further justification for that.
Okay. No, I am understanding in the right way. That is my question.
Mm-hmm. Yeah, you're understanding it the right way. Yes.
Okay.
Others, Ali, Bhavani, Fatima, Ria.
Which factor has more likelihood function or penalty? Which factor is more influential on the
Yeah.
IIC?
Yes, yes. Whichever is more influential would take AIC in their direction. Here, the penalty was more influential. Hence, AIC increased. Here, log likelihood became more influential. Hence, AIC reduced. So, depending upon which component is the more influential component, would take AIC in their direction.
If
Ria.
likelihood function is more influential, then a penalty, that means this parsimony has no effect.
So incrementally, if log likelihood has more impact, then technically what xi you have added inside the model is more powerful. Bhavani, Fatimatul, Ria, Ali.
Yes.
Yes, sir. What?
Great. So what I will do is, um, let's perform or let's use AIC on the empty gas data set using forward selection. Everyone, good to go till here. What are we trying to do here? So let's try to apply AIC on empty cast data set and try to see if we are able to perform or if we're able to understand that or not. Correct? Again, there are two key rules what you have to understand when you work with AIC. Lower the AIC, the better. Right? Second, AIC can be negative as well, just like you saw here on my screen. So in exam, don't get confused or don't panic that how can AIC be negative? AIC is not accuracy. Correct? So don't think of it like it has to be between 0 and 1, or why it is coming in thousands, why it is coming in lakhs, or why it is coming in negative lakhs. That is also possible. So don't panic. AIC can very well be negative. AIC can very well take large values in thousands and lakhs as well. All you have to see is lower the better, end of story. Are these two rules simple and clear for now? Why do I say lower the AIC the better? Because if I say higher the AIC, which means penalty is taking more control of the AIC, which I don't want. Hence, if AIC keeps on reducing down, I'm more happy because now I understand that the effect of penalty term is being wiped off. Is this simple understanding clear, everyone? Yes, no?
Yes, sir.
Yes, great. So whatever we learned in the forward selection, I am just using the AIC function as well here instead of the adjusted R square function. Correct? So instead of writing adjusted R square everywhere, I am just replacing it with AIC. So that we can just cross check and see if we are getting the same output or not. So that you can appreciate that, yeah, AIC also tends to work in a similar fashion of what we have learned. Everyone good to go? Let's start.
Yes, sir.
Great.
Yes.
So again, if you remember, the previous exercise what I had was weight, displacement, and Q-sec. So I'm using those exact three exercises again. I have a model here. What is the AIC of a null model? As discussed, it's not accuracy. So you will have some number. Great. It is 208. At step 1, I kind of calculate AIC for model weight. Okay. And similarly, I will have 3 AICs because I have 3 regressors, hence 3 competitions. My original AIC is 209 approximately. If you see, the moment I add weight or Q-sec or displacement, all AIC got reduced from 208. But which one of them is the minimum out of the 3? It is 166, which belongs to weight. So again, if you see, the answer is still the same. At the end of stage 1, weight enters the model. Simple. At stage 2, again, the story still remains the same. I will now add weight plus Q-sec, weight plus displacement, and try to see which AIC is now improving. Again, the model with only weight had a AIC of 166. Now, again, if you see, both of the models reduces my AIC. But which one of them have led to a greater reduction? It is weight plus Q-sec. So at the stage 2, weight plus Q-sec is my model. Again, at stage 3, you kind of again add displacement as well in the model and again calculate the AIC value. So now my AIC from 156 increases to 158 approximately, let's say by 2 odd units. AIC got increased, which means penalty is more heavier. So you will not keep displacement in the model because AIC increased. Just like adjusted R square reduced, AIC here increased. So 156 is a better AIC than 158. Hence, you would remain or you would stick to the AIC with 156 model. Hence, you say that weight and Q-sec are my final exercise and you conclude the process here.
There will be a
the
conflict
entire
of,
story makes sense.
there will be a conflict of results from AIC and R squared. Or both are correlated.
Yeah, absolutely. They are correlated in a way. So you would at times or majority of
That
the
is,
times you would see them moving hand in hand. Yes.
but minimum AIC is related to maximum R squared.
Broadly, yes, you can say that. Yeah.
So there won't be any conflict of results and all.
There may be at times if I change the penalty term, right? So if you see the AIC formula, kind of, I think I deleted that. No, I have it here. So I can change this penalty from 2 to 10. Right? So this is nothing but the heaviness of the penalty, how much you want to penalize. So 2, 20, 10, I can also try and control this off. So maybe depending upon that, things may change a little bit here and there. But broadly, yeah, as per defaults, these two guys should move hand in hand. But all you have to do is you have to choose either of them. Either you perform everything on AIC or either you perform everything on adjusted R square. Either of the method you choose is absolutely fine. There's nothing wrong in what you decide. If you feel AIC is more comfortable for you, great, go ahead. If you think adjusted R square is more comfortable for you, great, go ahead with that. It is just that I have introduced AIC now. We will obviously learn a lot more about it in our upcoming lectures.
That means they are going inwards. AIC and R squared
Yeah,
are
we kind of
moving
have a
inwards
negative relationship between them. If adjusted R square increase, AIC should reduce. Absolutely right, yes. Guys, is everyone clear? Ali, Anushka, Bhavani, Fatima, Tul, Riya, Tom.
Yes.
Yes.
Great. With that, can we stop here for the day? Let's see if backward selection on Saturday. I think we meet on Saturday next year. Yeah.
Yes.
It's already programmed in log likelihood is already programmed in AIC, right?
Yes. I just have to use the function AIC. Rest everything will
What
be
are the
taken care by.
components of likelihood? That the same that my MLE component only likelihood function.
Correct. Absolutely.
Same. But that also includes the x1, x2, etc. Correct? Likelihood. Likelihood includes x1 sample, x1, x2, x3 value also includes, no?
Yeah, definitely. It would include your y hat information and all that stuff as well.
So penalty variables also included in the exercise, right? The likelihood, right?
No,
Penalty
penalty has
variables.
nothing to do with likelihood, no?
Yeah,
Penalty
no,
is completely number of cases you have.
yeah, completed number of cases number only, but here we are using that variables also we are using in
Yeah,
likelihood.
definitely. Yes.
So there must be a correlation between this likelihood and penalty variables, right?
No, not exactly. That is why if you see, I never said AIC will only reduce. If there's a correlation, right? If there is a correlation term, then you are saying that with increase in number of excise, my log likelihood should either reduce or either increase. You are saying either. I am saying anything can happen. Even with respect to increase of your respective case, there may not necessarily be an improvement in your log likelihood. So it is not a one-way direction.
So one
And
more
it
thing,
will,
sir. If this there are the three variables x1, x2, x3, and this x3 is related to perfectly linear related to x2 and x1, then there will be this x1 and x2, x3 can be a garbage variable, right?
Yeah. There will be an issue of something called as multicollinearity.
Yeah, multicollinearity. Yeah, that is a
Yeah, correct. So
that
you
means
will
so it is
either have to remove you'll have to remove either one of them.
yeah, or that will be automatically AIC will be lower or R squared will be higher, right?
Correct. Fair enough. Guys, good to go, everyone. Yes, no. Great. So let's
Yes,
close for the day. Again, come revised before we meet for the next lecture, right? We will be discussing a lot about AIC and backward selection, stepwise selection. So it's always good if you are already aware, revised, and have your doubt sheets ready before we meet on in the next lecture.
Sir, here you are telling about this R programming only for AIC and all. If you can give that theoretical consideration of AIC, it would have been much better.
Theoretical consideration in the sense?
Theoretical derivations like or theoretical value of these likelihoods or examples like.
Log likelihood is already what you guys have studied in your CS1, right?
Yeah, we have studied. But if you could take an example also for theory, then it will be much better because R is everything is embedded there, no, in R programming. Or the command will give you everything AIC, right?
Correct.
Theoretically,
Let's see.
if you get it.
Fair.
Yeah.
Fair.
I'm just asking because theoretically it's already in R. It is everything is embedded, right?
Correct.
But in theoretical means it will give you a strong theoretical foundation. That is it.
Fair enough.
Actually, that CS1 they could have taught us in theoretical one CS1 they could have taught us. Otherwise, because CS1 itself becomes very heavy, that is why it was omitted. The GLM concept itself is omitted, right?
Correct.
So if we have some 10 minutes or some time in next class, some theoretical foundation for AAC, this likely AAC criteria, it would have been much better. Because whatever now we in practical point of view, AAC, we are taking our code and then writing it. Theoretical foundation would have been okay, no problem. If we have time, then only. I was interested, that is why.
Fair. Point taken. Maybe we can try to see if we can cover that later on.
I was interested in heteroceracity and multicollinearity also. I am interested. If you go into the deep it is very interesting. Right? That is the thing.
Correct. Fair.
Heteroceracity and multicollinearity, right?
Correct. Fair point taken. Point taken. Let's see. If we have some time left at the end, definitely
No,
we can
yeah,
try
I
and
don't know
talk.
other people have some problems or not, but I am interested in theoretical concepts more. Because
Mhm.
also I am in a rudimentary stage.
Fair. No feedback taken. Thanks for letting me the feedback taken. Let's try to incorporate these points as we move forward.
May not be for an exam point of view, but kind of a
Understood. It's more from an understanding perspective rather than curriculum based or something
the
like that.
ASC command code is itself in enough for exam point of view, right?
Correct.
But for theoretical foundation, it was by much better.
Fair. Point taken, Tom. Point taken. Feedback taken.
Because I'm interested in statistical parts. That's the thing.
No, I understand where you're coming from. Not at all a problem. Let's try to cover it in those areas. Definitely, that would be definitely interesting.
Some idea, some rudimentary idea. I will go to refer some books and I'll refer it. That's all.
Correct. Fair.
Yeah, this course will give you some broad idea. I'm not much interested in job or something, but just like that, it will give you more sharpen your brains. Like that's the thing.
Correct.